Okay, welcome back. Today I would like to show you the front axle of the Grader Revamp. So as you might remember from my previous videos, the front axle of the Grader is quite complicated because it has three functions: the front wheel drive, the steering obviously, and the wheel lean, so that the two wheels can tilt either that way or that way to act against the moldboard, adding a sideways force on the grader. So yeah, that's the new version. And in comparison, here's the old version without the motors, with the steering servo, and in here used to be a servo that did the leaning. So you'll see that they are not completely dissimilar, but yeah, basically I started from scratch and ended up in a relatively similar design. You need to tuck the motors as far into the wheels as possible. So you can see it's quite a tight fit. I have the pivot point is somewhere here, so I have a fairly good steering behavior. So when the wheels are steering, I'm not, if they were out here, I would be dragging them. I would be dragging them over the ground. So it's fairly neutral. And yeah, the other idea I had was to route the cables for the motor through these hollow pivot points. Yeah, so inside there is a brass tube, and the motor cables go into the black plastic that holds the motor and goes through here. So again, that makes it quite tidy. I'm going to use either rubber O-rings or tiny zip ties to hold the cables down. In hindsight, I would have liked a little bit more clearance than what I have. We'll see how it goes. No point in redoing everything now. If it chafes the wires, I will tackle that when we get to that point. Yeah, so I mentioned the wheel lean servo that I had in here. Oops, I'm still... Yep, so the wheel lean servo that I had in here. And there was quite a bigger problem because the machine is quite heavy, and if you want to tilt the wheels, the servo has to hold against that weight. Yeah, so you're wasting energy in the servo, which heats it up. So it meant that for this relatively, well, it's not an unimportant function, but it's not a function that requires a lot of power, or shouldn't require a lot of power. So I had to go to a high quality servo that can deal with that permanent force and that permanent torque, and therefore the heat. And then as you know, the servos start buzzing, and it's all a bit annoying. So I thought, that is an ideal situation for something mechanical that is self-locking, either a worm drive, or in this, what I'm using is a lead screw, so an M3 screw going into a female thread in brass, so relatively smoothly running. I'll try to show some details later. So we have in here a tiny gear motor, and this, so tiny gear motor, first pivot point second pivot point, and this brass sleeve has a female thread, and this brass tube is just as a dust jacket, so this is only protective. So I have one of these, and I have one of those M3 brass standoffs, and yeah, so I have these, and you can imagine if that rotates and that is fixed, as it is here, then I have a very compact lead screw arrangement, and that's exactly what I did. I'm using the servo mounting screw here as a pivot, and then I have rod ends connecting the two C's of the front axle, so that they both tilt in the same direction. What we see here is a miniature potentiometer that measures how much the wheels are tilting, and it sends that signal to a electronic from a servo. Yeah, so this is a standard servo electronic. Yeah, I just soldered off the potentiometer of the servo and soldered this one in, and then on the other side I soldered off the connections to the servo's motor and soldered this one in. So yeah, pretty straightforward stuff. A lot of work though, many small parts. I usually try to keep everything M3, but had to go into M2 territory quite a few times so that everything would fit. Yeah, all the cables are going to run through here up into the front frame. Front frame is here. So I suggest I show how it works. Using my trusty servo saver, which is out of focus, but you've seen it before. So it runs quite smoothly. The reason I'm using that as a servo and not as a gear motor is if I'm doing the wheel lean, you will see, I tried to get the geometry right, but you will see that there is a slight steering happening. It's difficult to see, and it might not even be enough to be a problem. But the idea is that if I know how much the wheels are leaning, I can use a mixer in my Turnigy 9X transmitter and compensate for that undesired steering motion of the wheels with a mixer. I've used that before with with the old design of the front axle. What I've done to minimize that problem is that we have a pivot point here. We have a pivot point here. We have a pivot point there. The pivot point of the servo sits exactly in line here. That point also sits exactly in line with that. So we have a parallelogram. So the only problem is that this point here sits like 3 millimeters too far in that direction, and that one sits 3 millimeters too far in that direction. I could try to remove that. I would have to have a third, so I would have one steering rod that goes from here to there, and then I would have a separate linkage from the middle of the servo horn to one of them. And well, currently I'm preferring this slightly neater setup, but I'm aware that the steering geometry isn't perfect, so I don't have much room, so as you can see, everything is quite tight here. So I do think it would be possible, but I would prefer... Well, I'm going to try this one first. Yeah, so I think that's pretty much all there is to say at this point. Not too long a video, considering how much time I've spent making all the parts. Yeah, the next steps are shrinking those heat shrink tubes, and disassembling everything. You've seen maybe a few black marker signs here and there. These are just edges, corners that I need to remove in order to get a higher steering angle. So that was one of the goals of this. Real graders have something like 50 degrees left and right, or even more, well, depending on whether they are all-wheel drive or not, but yeah, I wanted to get as close to 50 degrees as possible, and I think, as you will agree, I'm on a pretty good track. But the thing is that if you are also tilting at the same time, you have just interference with these on these edges. So there are a few points that need to be filed down, and then I'm going to partly reassemble everything and paint it. I'm quite confident that most of what I've done is acceptable, or will only need relatively small changes. So that's why I'm going for painting before the test drive. Also, test drive with all the cables and installation, that's always a bit of a nightmare. So yeah, I might change my mind on that, but if I do, you're going to find out just a couple of days after I've made the decision. And yeah, let me know in your comments what you think. I think this, obviously for Grader, the combination of driven wheels, leaning and steering makes things quite complicated, but I can definitely recommend using this polyacetal plastic. You can use a Forstner drill to drill holes that are the same diameter as your motor. Either you have a press fit or you have a slightly loose fit. If you have a slightly loose fit, you can have a clamping arrangement. It is quite a high quality plastic, so it takes, you know, it can survive quite a bit of force. So yeah, you can get it in white as well if you want to paint it. I've chosen black because it kind of like just disappears in the inside of the rim. And yeah, with a sharp Forstner drill, which I designed for wood, working with these is really quite simple. If you end up with a very cheap Forstner drill, then it can be a bit of a tedious affair, but yeah, so generally, yeah, and that allows you to build so basically anything, hold any round motor in place. I use them for the bogies. You can get this polyacetal on eBay, cut to the size that you need, rectangular, and that, you know, allows you to either mount it like I have, or mount it on a flat surface with a couple of screws. So yeah, that's definitely something that you know, I can recommend. You need to be a bit thicker than you would with aluminium, but and if you're hardcore, if you're building models that are really heavy duty, then that is probably not for you. But then you will probably have a milling machine, and you can do something similar in aluminium. If you just have a pillar drill, like I have, then the Forstner drill plus thick plastic is, I think, a very good alternative. Okay, two things I forgot to say. So if you compare where the motors are here and where the motors sit here, I do have more ground clearance than before. So that's another thing that is important for graders, because you have to drive over the windrow of your material that you have deposited in the previous pass. You have to go over that and yeah, not interfere with that, so that the mold board can move it then again further to the side for your next pass. Obviously, depending on what specific work you're doing with your grader. The whole thing is less symmetric than before, so you see that the motor has, as is common, has an eccentricity. I'll probably show that better here. So this is the middle of the motor, and this is the axle. So you do see that we have an offset between the two. And I have tilted that motor forwards. And that allows me to just use the space inside the rim. And that allows me to use the space inside the rim a little bit better. As you can see here, we have clearance here, we have clearance there, and obviously then when I'm attaching that to here, you see how the ground clearance is. Well, you don't see it because I have my hand in front of it. Yeah, but you can see, you can appreciate the ground clearance here. So yeah, this front axle should have better steering, better leaning, both in degrees and in function, and more ground clearance as well. So hopefully that all works out as I intended. And yeah, the other thing that I forgot was to discuss how the steering servo is arranged. So we have a PI 3402 Expert, made by Expert servo up here. Very strong. They call it 16 kilograms, so obviously kilograms is not a measure for torque, but that's what the servo industry has decided to use. So kilogram centimeters, sitting up here, and has a long 1/4 inch servo shaft that you can see here. And that allows me to move the servo arm, which I built myself. So that is the servo arm here, and that allows that arrangement to straddle the gear motor that does the wheel lean. It works okay on the bench. Hopefully, it works okay in the sand pit as well. Need to. So this is a brushless digital servo. Yeah, it doesn't get much better than that. Again, I don't need the speed it has, but yeah, it is something else. Really, I've used a lot of Zavux servos, and I can only recommend Zavux. But I feel, well, to be fair, I haven't really tried the top of the line Zavux servos, because I needed the low profile version here, so that I could fit everything in. And so Expert offers this digital brushless servo, which fit the bill exactly. So yeah, that's the steering servo explained, or the steering arrangement explained, yeah, I think this is now really everything, and I'm still grateful for you watching, and yeah, see you next time. Thank you very much.